Okay, this is our video lesson on how to solve a system of equations graphically. The reason I'm doing this on video lesson is because last year you spent a lot of time on systems of equations, and in geometry we just have to know how to do these things graphically. We don't even have to know how to do them algebraically. So here's our first question. It says, graph the following pairs of equations on the same axis and find the solution set for each graph. And I kind of gave you steps to do this. Solving a system of equations or a pair of equations graphically, what you want to do is first graph each equation. So I gave you two equations, and we're going to graph each one. Then step 2 says find the points of intersection. Another way to say that is where the graphs meet. And then you have to list the points of intersection and put them in a box as your final answer. So here are our first pair of equations. Y equals x squared minus 8x plus 15. If you remember from last year, when you have y equals something with a squared in it, this is a parabola. Parabolas can look like this or they can look like this, depending on whether the number in front of the x squared, if the coefficient is a positive. So if I have a positive x squared, it looks like this. If I have a negative x squared, it looks like that. And last year you should have done a lot of work with graphing parabolas. The easiest way to graph a parabola is to do it in your calculator. So here's how I would do it. Okay? You press the y equals key, and you're going to type in the equation. You're going to go x squared minus 8x plus 15. And what you do is you get the table of values. If you notice above the graph key, it says table in blue. So you press the second key, which is blue, and graph. And that gives you table. Now for a parabola, what you want to look for is a repetition in your y values. You want to look for a pattern. So if this is where my y values were, I don't see a pattern. I see 63, 48, 35, 24, 15, 8, and 3 as I go down. So what I want to do is I want to scroll and try to find a pattern. So I'm scrolling down. I really want my top and bottom numbers to be the same. So right now I have 48 and 0, no good. I have 35 and negative 1, no good. I have 24 and 0, no good. But if you see, now I have 15 and 3, but I'm starting to see a pattern here. I'm starting to see, oh, I have a 0 and a 0. I have an 8 and well, eventually it'll be, sorry, a 3 and a 3. So if we go down one more, we'll see that we have a pattern. Okay, look at your y values. They go 8, 3, 0, then negative 1, and 0, 3, 8. So the top number and the bottom number are the same. That's what I want. I want the top number and the bottom number to be the same. So I'm going to copy this table down. Okay? Actually, I'm going to kind of cheat here and just drag it. But you're going to copy this. You need to copy this table into your notes. So I'll give you some time to do that. So please copy the table. And this is for y equals x squared minus 8x plus 15. And then what we do is we're going to plot these points. So I'm going to go 1, 8. There's a point. 2, 3. There's a point. 3, 0. There's a point. 4, negative 1. There's a point. 5, 0. There's a point. 6, 3. There's a point. And 7, 8. There's a point. And here is my parabola. I put arrows at the end because these points are just representative of some of the points on the parabola. And you can see this thing opens upward. The x squared was positive. And I do want to write the equation on here. I want to write y equals x squared minus 8x plus 15. Now the next one, x plus y equals 5, we've graphed this here. There's no squared term. X is not squared, y is not squared. This is a line. So for a line, we solve it for y and get the slope and the intercept. So subtract x. And so we have y is negative 1x plus 5. So we have our y-intercept, which is 5, and our slope, which is negative 1 over 1. So we're going to plot this like we would any line. I'm going to start at the y-intercept. So I'm going to go 1, 2, 3, 4, 5 on the y-axis, and go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And if I wanted to go into the fourth quadrant and say I'm going to go up one and to the left one, up one and to the left one, up one and to the left one, and until I get the idea. And here is my line, which I'm going to graph nice and neatly. There's the line. Okay. And this is x plus y equals 5. And now I have to simply find the points of intersection and list them. So if you notice, the line intersects the parabola at 2 points. It intersects here, and it intersects here. So I'll circle them I can show the person that I found the intersection points. And now I just have to list them. Well, one intersection point is 2, 3. And the other intersection point is 5, 0. And I'm done. You have solved the system of equations, meaning you found the points that make the two graphs equal to each other. Or you found the points where the two graphs meet. All right. Very simple. All right, number 2, I have x squared plus y squared equals 16. Now notice, both the x and y are squared, as opposed to number 1, where it's y equals, the y doesn't have a square. Since the y and x both have a square, this is a circle. And we've graphed circles before. We did this the last few days. So x squared plus y squared equals 16. I want to figure out, well, my center of the circle is 0, 0. My radius is the square root of 16, which is 4, and I graph this thing. Center at 0, 0, and I go out 4 in every direction. And this is where you do have to kind of be neat about this. And there's my circle. Not too bad. Okay. Now I have 2y minus 2x equals 8. This has no squareds, so it's a line. So I want to solve this thing for y. So add 2x to both sides. So 2y equals 2x plus 8. Divide by 2 everywhere. And I get y equals x plus 4. And so I'm going to graph this, go up to 4 on the x-axis. And this time we're going to go up 1 over 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. If I want to go backwards into the fourth quadrant, I will go down 1 into the left 1, down 1 into the left 1, down 1 into the left 1, down 1 into the left 1. And here you can clearly see my line. And by the way, I should have been labeling this as we went along. So this circle is x squared plus y squared equals 16. This line is 2y minus 2x equals 8. And again, I want to circle there are actually 2 points of intersection in this one. I'll circle them, 1, 2. And so we have the point, let's see, negative 4, 0. And I have the point 0, 4. And I put these in a box as my final answer. And that's it. So here's number 3. I have x minus 1 squared plus y plus 4 squared equals 9. Since the x and the y are both getting squared, it's a circle. And so my center is 1, negative 4. We change the signs of what we see. And the radius, I take the square root, be careful, which is 3. And we're going to graph the circle. So my center is at 1, negative 4. There's my center. And my radius is 3. So I go out 3 in every direction. And I make my circle. And you know what? I don't like the way that came out. Maybe I'm being picky. I don't like the way that came out, though. I'll do that again. There it is. And now my other guy is x equals negative 2, which this is a line, but notice it's not in y equals mx plus b form. Okay? It's just an x equals, as Ms. Zal taught you guys last year, it's an excited line, which means it's a vertical line. It goes up and down. Another way to look at that is to say, well, if I go to negative 2 on the x-axis, I just draw a line that's going to cut the x-axis at negative 2. And here's our line. Okay, this is x equals negative 2. And as I said before, I should have been labeling as I go along. This is x minus 1 squared plus y plus 4 squared equals 9. Okay, and here is what we have going on. And this time, I actually only have one point of intersection. It's at this. This is called a, if you're going to be technical about it, it's called a tangent line because it only touches once. And this is vocabulary we will do when we're going to do a full circle unit. It's a tangent line. It touches once. Touches the circle once. Kind of grazes the circle, and we'll explore more about that. But for our purposes, we get the point of intersection, which is -2, comma, -4. And there's only one solution this time because there's only one point of intersection. Number 4 was on the Regents last year. It says solve the following system of equations graphically. So here we have 2x squared minus 4x equals y plus 1. And notice the y is not squared, but the x is. So this is a parabola. And we want to solve this for y because for a parabola, we want to put it in our calculators. So I'm going to subtract 1 from both sides. I'm going to get 2x squared minus 4x minus 1 equals y. And I'm going to put this directly into the calculator. So I'm going to clear out whatever's in there. I'm going to put in the 2x squared. Whoopsie, I need a 2. 2x squared minus 4x minus 1. And I'm going to go second graph to get the table, and I'm going to look for the pattern. So here's what we had before. On top, I have -3, and on the bottom, I have 69. That's no good. As you see, if you look at your y1s, they're really going big time numbers, up like past 7. So I'm going to go back. Oops, I got to do it from the x side. Whoops. You got to do it from the x column. I'm going to go back up. I don't quite see a pattern yet, although I do see the double -1s there. Up, still don't see the same number top and bottom of my y column. Up, still don't. Oh, actually, there we go. We see the same number top and bottom. We have 15s. So I'm going to take this table and copy it down. I'll just drag. I get to do that. So, but you have to copy this down. This, for the parabola, this is the work. You must copy the table. Otherwise, you don't get the points for that. That's the work that you do in the calculator to get the points for the parabola. Now, I suppose what's interesting about this one is that the parabola is off, that these points are too big. Now, I suppose what's interesting about this is that if we just use this grid that they gave us, the 15s won't fit. So I won't use the 15s at all when I graph. I'm just going to graph these points, which will be fine for us. So I'm going to go -1, 5. Here's -1, 5. I have 0, -1. I have 1, -3. I have 2, -1. And I have 3, 5. And maybe we'll need those additional points, and maybe we won't. But here's my parabola. Okay. Looks something like this. It's skinny, and by the way, you should remember this from last year. It's a skinny parabola because I have the 2 in front of the x squared, which makes that parabola become very skinny. So here is my graph for 2x squared minus 4x equals y plus 1. And now I need to make a graph for x plus y equals 1. Well, x plus y equals 1, since there's no squareds, is a line. No squared terms. So I subtract the x over. So I get y equals -x plus 1. So I have my slope of -1 over 1 and my y-intercept of 1. So I'll plot that. So I have -1x, sorry, my positive 1 here. And I'm going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Now, if I wanted to go the other way, I would go up 1 to the left 1, up 1 to the left 1. And so here's my graph. I missed that point, but that's okay. Now, if you notice, the red crosses the blue twice. One point is easy to get, and that point is 2 comma -1. This was a Regents question last year. Let me just put x plus y equals 1. And even really bright students failed to see that the red intersects the blue right here also. So there's another intersection point. Okay. Now, if we were to kind of guess, it looks like that point lies at -0.5 and and +1.5. If you kind of look, it's right smack in the middle of the box. So this is my guess currently. The guesstimate of this point, this extra point that's not on the grid, and this actually happened on the Regents, and they gave you the same exact graph paper. So I want to go -0.5, comma 1.5 as a guess. Here's -0.5, here's 1.5 as a guess. Now there's a way on the calculator we can actually get the intersection point. So let me show you. First things first, you type in the parabola in the y1, which we did, and in the y2, you scroll down to y2, and you type in y equals -1x plus 1. And now what I need to do to get the intersection point is to make a graph here. So I go graph. Here's my graph. And here's the line, and you can see it matches our picture identically, which is great. And this is another way you could check to see whether or not your graph is correct. It's just to physically graph it on the calculator. There's a nice little feature on here. If I press the blue key second, and I press trace, it brings me to this menu. And I would like to find out where the graphs intersect each other. So I'll hit second trace, and I'll hit the number 5, or I'll scroll down to 5 for intersect, enter. And it gives me this, the calculator actually asks you a question. The first curve, meaning what's the first curve that you want me to intersect? So y1 is in there, I just press enter. And the second curve is the line, I just press enter. Okay. And then the calculator asks for a guess. All right. At the guess, I want to scroll over. If you see, you can use your left and right arrow keys to scroll over. Let me make this a little bigger, actually. You can actually scroll over with your left and right arrow keys. And I want to scroll to this. And guess is a question. The calculator needs a guess to do what it does to get the intersection point. So I'm going to press enter at the guess. And if you notice, intersection is -0.5 and 1.5 for the x and the y value. So that's exactly what we wanted. Okay. And that's exactly what we have here. So the calculator does verify that our guess was indeed correct. Now here's the other thing you can do. Let's say you wanted to verify the other solution. I can go second, trace 5 again. First curve, I just press enter. Second curve, I press enter. And now I want to scroll over to the other point that I got before, just to verify to see if it works. Once you get to guess and you're satisfied that you're around the point, you press enter. And there it is, 2, -1. So this is an alternate way to use the technology that you have at your disposal to get the intersection points. So now your homework, if you will, is to do problems 5 through 8 on this worksheet.